getting started here. How many people we got on right now? Probably 20? I'm getting started just a little bit early. I thought I'd just pop on and like start warming up a little bit. Let's see here. I want to try to get a handle on where y'all are at in the chat. So today, I'm going to be going through one of the most foundational computer science topics. It's one of like the first algorithms you learn when you're joining when you do like a CS program. So this is like a great broadcast if you've never gone through a computer science program. Maybe you're a boot camp student or self-taught, or maybe you went through a CS program, but you just like need a little refresher. You know, maybe you just need a little update. What is this linked list thing? So why do you have to learn this shit, right? Why do we have to learn this stuff? Well, the biggest reason is obviously going to be interviews, right? It's like you'll never be asked to do a linked list on a whiteboard from scratch. I've never been asked that ever in an interview situation. But what you do have to do is they'll ask you a question and they're looking to make sure that you understand which data type it is and can you adapt that data structure to solve a problem. So today I want to introduce what a linked list is, and I also want to adapt that to something new, like a whiteboard interview type situation. Hey, I heard the sound of a new follower. I don't know who's the new follower though. Doesn't show anywhere. Anyway, thank you so much for the follow. Whoever you are, I love you so much. You're the best. So if in the chat, if you could let me know. Oh, I hear the sound again. Someone else, a new follower. Thank you. If you could tell me in the chat, like, what your experience level with algorithms is. If you're new to it, be vulnerable. Tell me. I want to know, like, who's here. What do you want to hear about? I also, hey, Victor, great. Thanks for stopping by, man. Yeah, I want to know. Ask questions while I'm jumping in here. Let me know if you're stuck on something, if I go too fast. We have a lot of shit we got to get through today. So, like, let's just jump in, huh? I'm trying to think here, too. Also, today I'm going to be presenting at Half Stack Online at 3 p.m. Central Time today. I'm really bad at doing conversions in my head. But, so let's just jump into this stuff, huh? I want to do a quick intro to linked lists. Again, let me know in the chat. What's your experience? Have you done linked lists before? What do you know? Who are you? What do you know? We got a Victor from Brazil. We got a Rebecca. We got them all here. All right. Very new. Cool. Unholy Glee. I'm spilling my coffee all over the place. Okay, let's just jump in here. Linked lists. A journey to data structures. This is a slide deck I put together about 4 years ago. Still good. That's the great part about algorithms and data structures. They do not change. Frameworks and libraries go away every single day. New ones pop up. Fundamentals never change. This is why it's such a good use of your time to be studying fundamentals. So, I'm not going to go through my whole thing. This usually takes me an hour to get through, so I'm just going to go through like a fast version of this. But I want to just introduce what a linked list is before we start live coding it. I think we can start digging into the structure of a linked list as we're programming it live. But basically, a linked list is similar to an array. It's just a list of information. But the way we traverse that information is a little bit differently. So with linked lists, or with an array, for example, right, you access data via indexes, right? You do like array, brackets, third index, right? So we want to get the third item in that, or the fourth item, right? So it's 0, indexed by 0. But it works a little bit differently with linked lists. In order to retrieve data from a linked list node, what you have to do, you start at the head of the node. So it's like the beginning of the array. And you go to the next item in the array until you find it. And it does it via pointer. So it shows you where the data is. And then the next thing is a value that keeps track of the pointer reference in memory of where that next node is. So with linked lists, the things you want to know is the head, that's the beginning of the linked list, and the tail, which is the end of the linked list. And each of the data values in between it, including the head and the tail, is a node. That's what we're going to call those. Basic vocabulary of a linked list. So linked list can look like this, right? We have the data we're storing in there, just like we would in an array. But unlike an array, we have that next value. And that next keeps track of where we're at. If the node is a tail, which means the end, it means it's not going to have a next. There's no next after it. So it's null. And in these nodes can exist in different places in memory. Can anyone in the chat guess why this is important? Why would we use a linked list data structure over an array? I think this is the question you should be considering, right? Let's see here. Looks like I got a question from One Punch Brothers. I'll get that in just a second, ma'am. Looks like it's a little off topic, so we'll get to that in just a second. So they're just data in memory. So it's interesting. It's important to understand when to use a linked list because you have to understand how the data structures get saved in memory. So in JavaScript, for example, if you're using an array in memory, what happens is the V8 engine pre-defines a chunk of data or a predefined space in memory where all that, there we go, gotta get it, where all that stuff is. So even if it doesn't use all that, it pre-allocates all that memory. If you run out, it doubles it, copies that all over to a new space of memory. The problem with this, though, is that array sizes are constrained to the size of the RAM, right? You can't, if you have 2 gigs of RAM, you can't have an array that stores more than 2 gigs of data. Max, right? Probably less, because other programs are probably using that RAM. But you cannot overflow that RAM. The data structure has to be contained in memory. Linked lists are useful for data structures where you are going to be containing data that's going to be larger than RAM, that can be contained in RAM. So a massive amount of data. Because, right, you could overflow to potentially larger sizes. You could go to multiple RAM. It's just a pointer in memory. You can point to other people's RAM. I could point to RAM in the cloud. I could point to RAM on your computer. It does not matter. You're just sharing where that data is. Oh, that's cool. That's cool, right? Like this data structure, we start talking about data at scale. Arrays work great for in memory. They're super fast. But there's pros and cons to using each of them. Okay, perfect. Oh, yeah, this is great. Performance. Understanding performance is key for understanding how to use them in an interview type situation or in real life. So, since we're saving these nodes in memory, right, adding things to the end of the linked list is really fast. We have pointer references to the head and the tail, and we instantly can we go to the tail and append a new item to that next. Easy. That's super, super fast for us. That's a constant time insertion into the memory. However, traversing linked lists is much slower than than retrieving data from an array. Why? So if you recall, right, we're gathering data from an array via indexing, right? So we just know we go to like this index in memory, and boom, that's our data is going to be saved in that place in memory. But linked lists, we have to traverse the linked list to find the data we need. We have to start the head. And if you know anything about Big O, which we're not going to talk about in depth today, that's going to be worst case scenario, that's going to be Big O of n. As an arrays typically have a constant lookup time because we know the index memory already exists. I'm going to say that again. Linked lists have a n Big O runtime for retrieving an item. So we start the head and we have to traverse that linked list until we find that item. Arrays, we know exactly where the index is in memory and we can just go retrieve that data. But adding something to a linked list is incredibly fast because we know we have a pointer reference in memory of where that tail is. And again, if you guys have questions, I know like we're skipping over a bunch of, this is the fast version. All right, this is the fast version of this. If you have questions or want to dig into something, let me know in the chat, all right? Okay. We'll go over this as a live coding it here today too. But, oh, this is kind of fun too. So there are multiple kinds of linked lists actually. Hey, sup Karen, woohoo! There's a bunch of different kinds of other linked lists here too. So we have the doubly linked lists. So, right, typically with a linked list, you start the head and traverse the tail. You can have a doubly linked list that has a next and a previous reference, so you can traverse both from the head and the tail. Or another thing that you might also see is a circular linked list. So instead of having an independent head and tail, the tail just loops back again to the head. The next reference goes back to the head. This is really useful for, if anyone can guess, right? When would like a circular reference be really useful? Let's say you've implemented a load balancer with a round robin type of bouncing strategy. So you're just going to different server nodes, distributing the load evenly, right? You just do that node. Or maybe you make a game, like poker, right? Where you're moving around a table. You have a circular data structure, so you could just traverse around all the players in the game. That'd be a great use case for that. And woohoo! I'm hearing another new follower. Thank you. Make sure you're following along. We'd love to have you. We stream every Friday at the same time. What is that? Noon Eastern time. That's when we stream. Okay. Let's see here. Does anyone have any questions about just like the basics of linked lists? All you have to really know is we have a head, we have a tail, and we're connecting nodes via pointer references. And we just do that through a next. We're going to be implementing a init and a get. I have all of the methods ready to go here. We're going to see how much time we have. We have an hour today. About an hour. But let's just like see what we can get through, huh? Okay. Oh, yeah, I also said one other thing, too. So we're going to be doing this with a MongoDB twist, right? So typically we save our nodes in memory. However, what we're going to be doing here, since it's the MongoDB stream, I want to be saving our nodes as MongoDB documents. So I actually think this is a great way to like explore just basic CRUD operations with MongoDB. But also, like this is persisting in a database or nodes, which actually could be really effective for like scaling this up in the cloud. And like I said too, this is an interesting adaptation of the linked list problem, which is similar to what you might experience in a real interview type situation. If you want to get better at data structures and MongoDB, this is a great way to kill two birds with one stone. Woo! Right? That's incredible. So hopefully today, the goal is we're going to get a little refresher. Maybe you're going to learn about linked lists for the first time. And you may even learn a little bit about MongoDB today. That's a best case scenario, right? Let's see what happens. Okay, let's see here. I'm going to try to pull up all my stuff here. Rearranging my windows. Anyone's new or doesn't follow me on Twitter, that is probably the best way to get a hold of me, just in general. Just like in general, you know? I'm on there a lot, tweeting stupid shit. I'm also on TikTok, which is really dumb. I don't know if anyone does TikTok here, but I do. Yeah, time complexity. We'll talk about time complexity. Let's do it right now. Let's do a quick little refresher on time complexity. So, Big O. Or let's see. So we have to talk about each of the specific methods, and then we have to talk about how the Big O runtime is affected for each of those, right? And we're going to talk about worst case, space, and time complexity. Actually, in this case, we're just going to talk about space. Sometimes it can be different. Typically the same, but that's not always the case. Especially with recursive methods. But for linked lists, inserting a new node into a linked list has a Big O runtime it's a constant runtime because we have a reference to the tail and we're just appending a new node. So we're just creating a new object in memory and then we have a pointer reference. It's constant time. However, the key difference here is with traversing a linked list or retrieving data from a linked list. The only way to retrieve data from a linked list, you cannot access it via index. You have to start at the head of the linked list and traverse the next pointer references in memory till you get that code that you want or that data. And that is a Big O n. Because worst case scenario, you could have to traverse that entire linked list, which have n items in it. Is there any, could you possibly lose reference to a node and like get a memory leak? Is that possible? Only if something that's corrupted in memory, which is incredibly rare. I've never experienced it. You're going to see here too, like, so we're going to be using MongoDB documents, and our next node is going to be the reference pointer we're going to be using is the object ID for that document in MongoDB. So the only thing that would happen if we like the data evaporated, You will have that happen when you're like developing the code for linked lists. You'll see that too. We're gonna have like some memory leaks. I'm gonna write some code to help remediate that, so it makes it easier for us to develop. But no, it would have to be like a system issue, but it's never been a problem. Increase the font size. Thank you. Yes, of course. Also, chat. I'm curious, is my voice loud enough for everyone? I hope it's not blowing out your speakers or causing any eardrums to explode. I don't know. Whatever. Let me know if you need me to adjust the volume as well. Okay, let's see here. Oh, yeah, I have another question from the One Punch Brothers that I other than knowing data structure and algorithms, what kind of software engineering project should I create in order to land a job at MongoDB or anywhere else? Should any projects be more based on web development or similar to something else? Thank you, Rebecca. That's great. So One Punch Brothers, he's asking, what kind of portfolio project should I make in order to land a job at MongoDB? Which, by the way, MongoDB is hiring right now. If you go to careers.mongodb.com, we're always looking. I think we're currently looking for intern class. So if you're a college student, this is great. You should totally come out. You should totally apply. Even if you are nervous about it, you don't think you're good enough, let me know. DM me on Twitter, and I will personally refer you also if you want to, and we can talk about tips for how to do that too. I do a live stream every Wednesday on my Instagram, and I answer career tips about the stuff. So if you want to join that, you should totally follow me on Instagram. It's just Joe Karlsson, like my GitHub bio in the upper corner over there. Hey, we got a follow, thank you. But in regards to projects, it doesn't really matter. Do whatever you want, man. It depends what you want to do, right? Like at MongoDB, we hire for pretty much every programming language because we support most of the major drivers. Go. I don't think we have Rust, but JavaScript, Node, Java, Python. I don't even know. We have a ton, right? We have a ton. PHP, right? It doesn't really matter. Work on, like, my recommendation would be, like, just work on shit you like. If you like web development, fucking go for it. If you love database development, cool. If you love servers, if you want to do, like, DevOps stuff, cool. We pretty much hire for anything, and it doesn't really matter. Honestly, too, I've never interviewed for a job where programming language or your specific portfolio projects actually matter. What you're trying to demonstrate is that you're good at learning and you're invested and passionate about programming, especially if you're a junior developer who's self-taught. That's essential for landing a job. If you start doing some interesting projects, that's huge too. Honestly, though, for me, I'm more concerned about, are you collaborating with other people? Are you working at open source work or building with teams, working at hackathons? If you're like, because I don't want to hire a lone wolf on my team. I want to hire a great team player who's passionate about learning new shit, who's going to be able to pick up new stuff, and I'm not going to have to worry about him if I hire him. All right. Great question, though. I know. Get a job. Apply for MongoDB. Lots of great jobs over here. I love it. It's one of the best jobs I've ever had. Okay. Let's see here. So first of all, what I want to do is... What do I want to do? What am I doing here? Oh, I know. Okay, cool. So first thing I'm going to do is I have a new project just set up here. I've already done an npm init, as you can see here. But I want to do an npm install. I'm going to save it as a dev or as a production dependency, and I want to install MongoDB because we're going to be using MongoDB to connect to the cloud. And the next thing I want to do then is just get our linked list kind of set up here. So we're going to be doing this via OOP. We're going to be doing OOP methods. Oh, and I'm going to be showing you guys our brand spanking new MongoDB Visual Studio Code plugin. Yes. But let's just get this shit started. Thank you for the follow. Who are you? I don't know, but I love you. Thank you. What's in the cup? I've been making iced coffee. Iced coffee. I switch over once it gets hot. I make like a gallon of iced coffee a week, and I just sip on that shit all week long. All right, let's get this party started. Let's get it started. So class capital linked lists, right? Because it's the best practice to use capital or uppercasing for a class, and then you do camel casing for in an instance of a class. So we're going to make a brand new MongoDB class. I'm not going to do constructor because I don't think we actually... need one. But I do want to make a method in it. So, and the reason I'm not going to put this in the constructor is because it's going to be an asynchronous function. Because our async, we want to connect to the MongoDB Atlas cluster in the cloud. So, luckily for all y'all, I've actually already got a MongoDB cluster created in Atlas. So we're going to be doing this in the cloud. If you want, you can totally use, if you want to get free Atlas credits, use Joe K100. You get $100 in free credits. But we do have a free tier. This is built on the free tier. It's to be free forever. No worries. It's amazing. It's just MongoDB, but you don't have to set it up by yourself anymore. We handle everything for you. It's incredible. Point is, though, I got some documents. I got a MongoDB database and collection already set up in the cloud. Let's see. I'm going to reset this. Whoops. Oh. Yeah, whatever. We'll clear this out. This is from when I was setting up the demo. But cool part about this, though, I want to make sure I can connect to this thing. So let's go to clusters. I'm going to hit this connect. Cool part about this, you can actually tell it to connect to your application, and it shows you all the languages we support. I'm building this in Node.js. Oops. Not Java, in Node. And using the latest LTS. And you can actually click this button, and it gives you all of the boilerplate code you need to get it set up. So the only thing you have to do is replace your password for the user I set up in memory. I'm just going to copy pasta this down here, and then we can go ahead and start messing around with this and make this work. Okay, so I'm going to, first, we're going to require this at the top of our thing. Right, we already did an install on that, npm install, so that's not a problem. And then the next thing I'm going to do is do an async up here. Okay, the next thing, actually, I want to do a, awaits on this instead, actually. Instead, by default, they do a callback function. Cool. Since we're doing async await, let's just convert this bad boy over here. Okay. Password, there we go. So I'm going to do some try catches on this B. Ooh. All right. Try, and I'm going to do an await, and because we have this synced as an async method, this should not be a problem. We can now use this, and we're going to do this dot, I think it's this dot client dot, so we're going to be making a client attached to the class. Oh, it looks like my camera's all blurry. I got this new 4K webcam, and it's amazing clarity, but it sucks at autofocusing. It's so bad. Maybe I'll try to wave, make that, does that help? Focus on my face. Okay, whatever. It usually just, it'll go, but it takes a while. It's clearly focusing on something right up close. Look at that. You can like see my, can you see my like fingerprints? Okay. There we go. It's focusing now. So we're going to connect. And let's just do a little, we'll just do a little console log. Make sure that we're good to go. Console. Oh, that's great. We'll auto connect, and we'll do connected to MongoDB Atlas. And then we have to connect it to our collection. So once it gets connected, right, we're waiting. We do this, and I have this in our, where did I put that? Where did she go? Where did that go? I'm gonna pop this. Actually, you know what I'm gonna do? I'm just gonna pop this right over here, and we'll put this to the side over here. We can kind of look at both of them. So let's take a look at these collections. And we got our demos.link list. So we got database is demos, and our collections is linked dash list. Okay, and then I'm going to delete this whole thing because we don't need it anymore. And you always, always, always want to put a catch. Always do error handling. Even if you don't, like, it's probably going to work. Doesn't matter. Put error handling on it. You'll thank me. So we're going to do console.error. And we'll just do err.stack. All right. Okay, cool. So let's see here. Let's test this bad boy out, huh? So what we want to do then is we want to instantiate a new instance of this new MongoDB class we just created. Yes, OD01 or 01. The await command is part of the async code, right? Yes, it is. Yes, it's a new built-in data type. So you have to put await. If you want to use await, you have to make the function you have to call asynchronous. You have to designate that it's an asynchronous function. I'll show you what happens if you don't in just a second. So let's go ahead and actually create this thing, huh? So again, since we're using async, I'm going to make a asynchronous iffy, or immediately invoked function expression. And Karen doesn't handle errors. Karen! Yeah. I do too. It's we always try our best. Oh yeah, shit, I have to delete this. Okay, so again, I'm gonna make an immediately invoked function expression, and let's go ahead and do that. So we'll do async function, and if you make an iffy, you have to immediately invoke it, right? So that's how we do there. There we go. Now we got a little iffy. So now that allows us to do try. Oops, I thought that was gonna do a try catch. There we go. Thank you. And again, right, we're good programmers. We're just gonna catch our errors right away. Always catch them. And there we go. And then try. So I'm gonna use our linked list, right? And we're gonna be using our camel case this time because it's an instance of a class. We're gonna instantiate a new instance of the capital L linked list class. See how that works? And there we go. It has no constructor argument, so we can just invoke it. But if you recall, right, we didn't put that in our constructor because it's an asynchronous function. You cannot have an asynchronous constructor function. So that means that we have to invoke init afterward. So we'll do an await linked list dot init. There we go. So now we should be able to see what happens here. I'm going to go down here. I'm going to run nodemon. If anyone doesn't know what nodemon is, it's node, but it basically just does every time you save, it'll rerun your code. So I don't have to keep rerunning this whole thing over and over again. But app.js. Okay, interesting. We got a... Oh, I think it's because I called client incorrectly here. New MongoDB client. Oh, I see the problem. So I have to do, I have to attach this here if I want to access it. There we go. So now we're connected. And we got another client is not defined. That's okay. There we go. Gotta fix that right here. Remember, test often. You know what else I'm going to do here is, let's see here. I'm going to actually make that go away. I'm going to actually just console log our collection here and see if we can see everything. So CLO, and we'll do collection. If we can see the collection data from Atlas, it means we're good to go. Hey, look at this. Down here, we could see all the data from our MongoDB collection. This is everything you get when you console log it. All of our options, everything we can possibly do with it. And Unholy Glee, yes, you're asking, yeah, MongoDB University. I think that's in here. Oops. How do I do there's I can't remember how to do it. It's university.mongodb.com. And if you're brand new to MongoDB, you should check out I recommend checking out our M001 course. Let's see, I'm going to try this really fast in the chat too. No. URL bang? I can't remember. Dang it. Whatever. Can't remember how to use our shortcuts. But anyway, if you're new to MongoDB, check out our university course. When I got hired on as an engineer at MongoDB, oh, I know. Sorry, Rebecca. I don't know how to do chats. But I went through our MongoDB University training to be trained on as an engineer at MongoDB, and it's incredible, and it's free and open for everyone. You should totally check it out, though. And now I'm realizing too the chat's kind of covering up some of the. We'll move it around if we need to, but okay. Let's see here. So point is, we got our connection here. The next thing I want to do then is I want to kind of reset our. I want to reset the data. So right now, if you look at our collection here, I have a bunch of the data I had from before. And every time I want to develop it, I want to clean out that data and reset all of it. So what I'm going to do is, and thank you for the follow. Who is it? Yes. Free 99. That's the best price. It's incredible. Let's do a reset data. So I'm going to do the same thing here. I'm going to make a new function. We'll call it reset. We'll call it like reset atlas data. And all it's going to do is just delete everything in all of our data. I want to do that because every single time we run this, I want a clean slate. So, how do we do that? Well, it's another async. We want to wait. It's going to be asynchronous, right? Any database call or anything over the wire, that's an asynchronous event. But I just want to do this dot collection, and I want to start doing some work on that. I'm going to do just a CRUD operation, and I'm going to do delete many, because I want to delete 1 to n items in there. And I'm going to do it based on exists. So I'm going to do if, because if you look in here, I have the value or data. And if that just exists in there, I want it gone. I want to nuke it, right? Let's do that. We'll do a, where is that? Bling. And basically that means if that value true exists on any document, I want to just delete it. Get rid of it. So let's test this out. We're going to init. That's going to connect to our atlas. Then I want to delete any of all the data in here. Ooh, we got an error is not defined. Oh, that's down here. Something errored out. That's okay. Cannot read delete many of undefined. Oh, I know the problem. Because I have to do, instead of doing const, because that only exists in that thing there, we need to make sure we're connecting it to the linked list object, or the class, so we can access that elsewhere. Okay, collection is not defined. Why is that not defined? Let's find out. So let's see what line it's failing on. So it's line 12. Oh, I know it's failing because it's this console log. Let's get rid of that because that's annoying anyways. Okay, looks like now we have a equal sign. Okay. Unknown operator exists. I think it's exists. There we go. Cool. Connected. And I'm going to do a refresh. And we should expect to see all the data gone that has a value. Woohoo! Oh! This is a great time to plug our MongoDB thing. All right, so we have the MongoDB. Where is it? MongoDB. Maybe I got to install it. I'm using a new computer here, so it's kind of fresh here. But let's check it out. I'm going to do MongoDB. And we have our new MongoDB Atlas, or MongoDB for Visual Studio Code plugin. There we go. Okay, so now let's see if this works. I'm going to do a, oh, look at this. We got a little thing down here. Add connection. So we got to tell it where our thing is. How do we connect with a connection string? There we go. So we just paste that connection string that we had in here. So let's go back over to overview, cluster connect, and I got to get my connection string. There we go. That's this thing. I'm going to copy this and connect to the connection string. We got to put that in there. And then put your password in there. I'm going to delete this right afterward, so it shouldn't be a problem. But hey, successfully connected. So now there we go. And you can see our demos, our linked list, and all of our documents. There we go. Woohoo! Look at that. Now we can see all of our documents in Visual Studio Code without having to leave. I'm still going to keep this up, but like, I think it's pretty cool. You can see everything from here, right? You can see all the documents from our Atlas cluster in the cloud right in Visual Studio. You don't have to leave it all. Damn. Isn't that cool? Isn't that cool? Oh, thank you. Yes. We just released it. If you have feedback or thoughts about it, it's been well received by the Node community, but hey, what the hell? You know what I mean? Like, if you have thoughts about it, let us know. We'd love to hear about feedback from like real devs actually using it in the wild. Okay. So that's how that works. Actually, you know what? Whatever. I'll just put this over here for now, and we can see what happens. So we have our Atlas cluster here. We're deleting many. Cool. We're cruising here. We're cruising. What do we want to do next? Yes, the other thing. So right now we have one document in here. Where is it? There we go. And that is our meta head. So this keeps track of where our head and tail exists in memory. I basically just inserted this, but I want to make sure we're resetting this because it still has head and tail data from before. And an empty linked list should have 0 references to a head or tail. These are object ID references to another thing in memory that doesn't exist. So we need to basically reset that as well. I'm going to do something similar. We're going to do I'm going to call it reset meta. And we're just going to reset that. We're going to reset that meta thing too. So we don't need to delete it, which we totally can. But what I want to do now is instead update our existing head with or upsert an existing one. So let's figure out how that looks. So instead of delete many, we're going to be using update one. So we only have one. We're going to be using one document to store all the metadata information for it. So update one. Typing's hard when you're streaming. Does anyone know that? Update meta, update one. Okay, great. Oh, cool, awesome. Looks like this MongoDB plugin also gives you some information about how to use the methods that are built in. That's pretty handy. Damn. So I want it to be meta, if it's true. That's the one we want to hit. That's our query. So if meta is true. Okay. And then we want to do our query. Oh man, it walks you through it. So this is the query we want to actually make on it, or what we want to do on that thing. And I want to set. Let's see here. Can I do this? We'll do our. We want to reset our head and our tail. So we'll do head. I'm gonna do null. Null is a great one for just designating that you want it to be empty. We're intentionally setting it to be empty, not undefined. It's null. And we want to also make sure that we're resetting our tail to null. Okay. And then lastly, I like doing this too, just in case it doesn't exist yet, but I'm going to do an upsert. Upsert basically means if it doesn't exist, I want you to insert it in there. If it already exists, just do an update. It's a good, healthy way to do it, especially as we're kind of resetting the data every time. It just makes sure that we're all good to go. Also, if you're doing this at home and you haven't already initialized the metadata information yet, it should still work. It should still work for you. All right, looks like we got extra parentheses here, checking everything out, making sure it looks good. All right, and let's test it. So we're gonna do the same thing. We're gonna reset our meta, and I wanna make sure that this now should be head and tail should be null. So I'm gonna save this and open this up. Can I do a refresh on this? There we go. Just have to open it again. But now I have it meta, which is like metadata. It designates that it's a special metadata document, and we keep track of our other documents in there. But we have our head and tail. Woo! Am I right? Isn't that cool? Looking at the chat. All right, cool. So we now have a function to kind of set this all up. We clear out all the old data, and we're resetting the metadata every single time we save. It's doing this. That means we're gonna have a clean place to start here. Wow, that took us a long time to get here, but hey, whatever, right? So let's start with adding. Duh, we have an empty linked list now. What the heck we're gonna do with that? Let's add some shit to it, right? And then we could start retrieving, getting, updating, whatever. We can do all that. So let's just start with add. Async add value. Okay. So adding. Let's review how adding works again. Adding works by, actually, you know what? I'm going to pull up that slide deck again here. Slides, great. Again, these are my old slides here, but let's pull this up here. Okay, add a node. We didn't go over this, and we'll go over it now. So to add a new node, what you do is you put a new node or a new MongoDB document to the current tail. And we have to update the tail's next value to be the new node we just created. And we also have to update that metadata information to be a pointer reference to that tail. So let's start with the first step here, adding a new node. I'm going to do, you know what I'm going to do? I'm going to make a I'm going to make another function that makes a new node. And a new node for us is just a new MongoDB document. So I'm going to make a new function. We'll call it create new node. And we need some sort of data in here. So we'll do like data. Whatever we're saving it. Number, integers, massive amounts of data. It doesn't matter. Whatever we want to save in there. And just make this a little bit smaller so we can see a little better. Make that a little bit smaller. Okay, great. So we're going to be creating a brand new MongoDB document in the cloud. So let's just go ahead and do that. Const new node. Oops. Gotta be camel case because it's not a class. It's an instance in memory. And we want to await for something to happen. We're going to do this. Do some work on the collection. And we're going to insert a new document into that database or into that collection. And we could just, this is super easy. You just define the structure of the data that you want to put in there. So we're going to have our value. It's going to be whatever value you have in there. And then we want to keep track of the next pointer reference. Since it's a new node, we're just going to do next because we're assuming for inserting it, we're going to put it in the end. We're going to put that at the end of our linked list. So it's going to have there's going to be nothing after it. Inserting, it always puts it on the end of that linked list. Okay, and then all I want to do is return new node. So we can use that data once we wait back from it. So let's actually just go ahead and console log this, make sure this is working as expected. And maybe, you know what, let's do this. So we'll do our, on our add method, let's go ahead and just invoke it, and then we can test it out. So we'll do const new node equals, we want to await this dot create new node. And we want to put some data on there, which we're just going to put value from when we create it. All right, and since we're good programmers, we want to test often. So let's go ahead and go down here. We've reset everything. Now I want to add a new node to our linked list. So we'll just add cat. Value is not defined. Okay, cool. It's because I called it data here. Let's be consistent. And new node. Hey, there we go. Look at this. You can see the data we're retrieving back in memory. Inserted one count. That's awesome. Gives us our inserted ID. Bunch of information. Also, let's go ahead and take a look at this. Okay, we got that one. Hey, there it is. Right? Now, in the cloud, we have that new document being saved. I'm even going to show you here, too. I'm going to pull up Atlas in the cloud so you can see that there as well. There we go. We're going to go to our collections. Refresh. And we should see a meta and our cat. There it is. So we've created a brand new document in the cloud. But now we got to do step 2. Right? Or this another part. We have to add new tail to the current tail. Okay. We're going to be keeping track of pointer references to this via the IDs. These are the auto-generated object IDs we get. Okay, so what do we do there? New node. I want to just pull it off. So since we're sending that data back, right, you can have all this. It also gives us back our inserted ID. All I want to do is just pull that off and then use that. We're going to be saving that object ID as the reference, the tail reference for the next node. So let's go ahead and save this. So we'll do const inserted ID. That's the new node. Maybe we'll call it, actually, you know what? Let's call it new node ID. Just to be super clear. I like being explicit, very explicit when I'm defining variables. I don't want there any confusion, and I need to be consistent as well. So we'll do result dot, we'll do new node dot, right, this little thing on here, right? We'll just go insert ID. There it is. And again, let's test this console log. New node ID. Test often. There it is. Look at that. Woohoo! Now we have a reference to the new node created, and we can now update our tail with that information. Okay, so bunch of stuff we have to do here. Bunch of stuff. There's a lot of different cases that could occur when you're adding a new item to a linked list. So in this instance, right, we have an empty linked list. There's nothing in it at this point, right? So both the head and the tail are pointing to the same node. Because they both are the same, right? There's one node, it's the head, the beginning and the end is the same document. So we have to make sure that we're counting for this case. So how do we tell if the linked list is empty and we're adding our first thing? Well, if we look at our meta node, right? We know it's empty if the head is null. If there's nothing in there, we know it's an empty linked list and we need to do some work with that. Okay, that's good. That's good. That tells us something. So we'll do if. Oh, let's see here. So we got to get that head first. So let's write another meta function here, and we'll call it getHead. That sounds gross, but hey, I wonder, can we do an asynchronous get method? Let's try this. This may be fun. Asynchronous get. Call it getHead. I have no idea if this is gonna work. This will be fun. Because we have the get method. Oh, I have no idea. Let's find out. Looks good, and it's not nothing's complaining. Nothing's complaining because with classes in JavaScript, you have a built-in key value or key type or restricted name, which is get and set, which is great. So let's just go ahead and see what we can do here. Get head, and what we need to do is get information about the metadata. We got to go get that meta information. Actually, you know what? I'm going to do another one. This is called get meta. I love being super explicit about methods and breaking it up. I just love it. Get meta. How do we do that? So we need to go ahead and we just need to get that data that has that meta designating on it. So we have that meta keyword on it. Where is she? There we go. We have to look for the document that has this on it. Okay, that's easy. So this dot, oops, we wanted to do a const meta equals await this dot collection dot find. We need to look for a document that has where meta exists. True. I think that's it. I think that's, I wrote meet there too, I see. And find returns a pointer reference or a cursor. So I just do next and basically just converts that for us. So let's first change this. We'll do meta return meta. Oops, not metal. Next thing I want to do is console log meta. Next thing I want to do is invoke our get meta. So let's see here. How do we do that? That should just be. How do we do that? Chat. Let's see here. We'll do. Can we do it? I need to await. I'm gonna see here. We'll do const meta is equal to this dot meta property. Let's just see if that works. Let's see here. I have no idea. Or is it a function? I can't remember if it's a. And then I want to do console log meta. Actually, you know what I might do is pull that out. Asynchronous get meta. Okay, whatever. I'm just gonna do it this way. This dot. Okay. And we need to invoke that function as well. Okay, get head. We'll do the same thing here. We'll do our get head. And then we also need to go ahead and make sure that we're pulling that through correctly. So on our add method, let's go ahead and we'll just go and get head. Okay, get head. Call it const head equals this dot get head. Hey, we got a new follower. Thank you so much. All right, I think that should be good. And then we'll do some work with that in a sec. But let's take a look at what we got here. Oh, we got a bunch of stuff. It's returning back a pending promise because we forgot to put a await on it. Still got a problem. Oh, it's because of this one. Got an await. Just following that chain up. There we go. Meta. So it gives back that meta information for us. and head is null. Okay, perfect, great. Okay, and we want to return meta.head. Nice. That looks good. That looks good. So we're using this method. We can reuse that to get our tail, and then we just go get the head, and boom. Oh, let's see here. Actually, you know what? We'll do CLO. Let's do a cleanup on here. Where did the new node? We can nuke that. Hey, we got a new follower. Thank you so much. I'm gonna delete this new node. Great. Hey, there we go. Head is null. Oh. So, as we said, now we know that we have an empty linked list. We need to add that new method. So, all we have to do is do if. Oops. Can I use the if statement here? If condition. So, if head triple equals null, we need to do some work. This is our, and I like to put a little note here about what this is. So, this is our initializing a new empty linked list. Or adding, let's see, adding a node to an empty linked list. So if the head is null, it means that the linked list is currently empty. And what we need to do then is we need to set the head to have that, with that new pointer reference, that new document we just created here for this new node ID, right? So let's do another function. We'll do a similar one. So instead of getting now, let's set it. We need to set the head with that new information that we just created. So very similarly, we have that we want to update that meta document with that new data we just created. So let's do something a little bit different. We're gonna do an update one. Did I do that before? Yes, here we go. I'm just gonna copy pasta this and set head. Instead of doing resetting it to null, what I want it to do is reset it to our ID. So this is we'll do new node ID. Cool. And reset head. We want to set the head to the ID. Head. Instead of null, we do that, and we don't touch the tail. All it's doing is setting that head. Upsert. No. Okay, cool. So I like to do this when I'm programming. I like to make sure that it's I want to make sure I'm figuring out ahead of time what I'm expecting. I see a lot of junior developers who go through and they just are blindly trying stuff without guessing. Try to get ahead of it. In this case, I'm expecting now that when we run this, actually we haven't done that yet, so we have to do our set head. So we do this dot set head, with the new pointer reference to our new document in memory, and we just do that with our new node ID. So now what happens? We should expect to see our metadata be updated with that new information. And I'm going to save it. And let's see here. So we have our cat. And this is what we have here. I just like looking at the last one. 3C64. And I want to go up to our meta value. And we should see that head reference there. And our head is updated with 3C64. Yes. Our head has a pointer reference to a MongoDB document elsewhere in memory. Woo! It's initializing an empty linked list correctly. Oh my god. And I see someone in chat's asking, is this JavaScript? Yes, it's actually Node specifically, but same difference, right? Okay. Yeah, keep asking questions. If I'm moving fast, something doesn't make sense. Yeah, I'll slow down. I'll slow down for you. I'd love to jump in too. Okay. And we also need to make sure we're updating the tail. So let's go ahead and create a update tail function, right? Because the head and tail are now pointing to the same place. So, I don't have one yet. Our get tail. That's okay. So we have our set head, and I want to do a set tail. And we'll do the same thing. The only difference is when we set our tail there. And then let's do our update this. We'll do an update tail. Boom. All right, so now we should expect to see our head and tail be initialized correctly when it's empty. So I'm going to open this up again. Boom, we have this. We have 7-4. We'll do 426F. Should see that there for head and tail. And boom, there it is, 426F. We're updating the pointer references because there's a single node in there. So the head and tail is the same document. So we can just go ahead and we show it to the same place. Okay, but now you should be thinking to yourself, we've talked about the situation where the linked list is empty, but what happens when we add another item to this linked list? So now we have our dog. We're going to create a cat and a dog to our linked list. We go over here, right? We have our cat and our dog is now being created in memory. Holy cow, right? Wild. But right now what's happening is it's not null anymore, but we need to update something else. Let's go with this. Now we're updating, we have a linked list that isn't empty. So head is not null at this point, right? If you go in there, head has data in it. It's no longer null. We need to handle that use case. So what do we do next? Well, good question, right? Let's go ahead and update this. So else, this is going to be our case where adding a node to a non-empty linked list. Oh my God, right? This is wild. So what we need to do is update the, because we're adding and inserting a new item. The head is the same, right? It's still pointing to cat, but now we have our dog document. We need to make sure we're updating the tail to reference that new document. So what I'm actually going to do is just update, I'm going to move this out because we need to update the tail no matter what, every single time. But the point here too is we need to update the previous node's tail. We have to get the old tail and we have to update that next reference to the next linked list. Oh my gosh, right? So let's go ahead and do that. Instead of getting, we're going to just do our get head here. So we'll do same thing we did here. Oh wait, and then instead of getting the head, we just get the tail. Don't need that. Great. So now we want to go ahead and get that tail. And we need to check to see then we have to go to the old tail and we have to update this next reference to the new document ID that we just created. So we go and get that tail. And we have to update that tails. So that's the old end, and we're appending that new item to it. So now we have to do that next reference referencing the new document we just created in memory. So, and instead of head, we'll do tail. Great. And we have to do an await on it. So await this dot collection dot update one. So we have to update that old tails. Update one. Great. And we know where we have the pointer reference to it, right? Because we have that tail. We know where that is. That's our old metadata tail that we had before. So we're just going to do we're going to go do a find for that ID. And we'll just do tail. Actually, no, we'll call this tail ID. Just to be very, very clear, right? Tail ID. And what do we want to do with that? Good question. We want to update its next value with the new node's ID we just created, right? So we want to create that link in memory, that pointer reference via an object ID that we just created. So we'll do a set. Whoops. It's a bling set. We want to update that next reference to the new node ID we just created. Whoa! I think that's good. Yeah. And then we update this. Okay. So let's do a bump, 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 bump. Oops. This looks like it's not formatted. Format document. Oh, looks like I'm gonna do a preset. There we go. Woo! Much better, much cleaner. So now this should actually be done, right? We're initializing, so cat's being sent in first. We're updating the head and the tail. Then if the head is not null, we know that it's going to be in the middle. So we have to update the old tail's next reference to be the new node. So it points in memory to that next node. And then lastly, we update the metadata tail to point to the new document we just created, new node ID. Woo! So let's go ahead and take a look in memory and see if this is working as expected. So I want to look at the 2 documents we created. Actually, you know what? I might just pull this up. It's kind of nice to see everything all at once. And let's do a refresh on this. Okay, so we have our cat and dog. And let's take a look at how this works. This will get a little bit bigger. Okay. And we have our metadata. And let's see if these are created correctly. So we have our cat is inserted first. So our head should be pointing to the cat reference here. As expected, we have C117 right down here. And head is pointing to that correct cat. And our tail is C118. And you can see that that's pointing to our second inserted linked list. Our head and tail are being set to the correct item. But the next thing we need to figure out then too is our pointer references working correctly? So cat's inserted first, and the next value that's going to be pointing to should be our dog, which you can see here C118. It is pointing to that correct dog document. And dog, since it's end of the linked list, there is no next. So its next value is set to null. Isn't that wild? Let's try this again. Let's do another one. So let's do, and we should be able to add infinite number of things now, and that pointer references should be working correctly. So fish, and then maybe we'll do a turtle, and let's do a refresh. So we have all these documents created here. Cat is still at the beginning, so that cat's object ID should still be 36D9. Boom, right here, 36D9. The head is still set correctly to the cat. The cat's pointer reference next in memory is 36DA, which, as expected, is our dog's object ID. And the next one we created is a fish. So let's take a look at that. So dog points to a document. It's called 36DB. And boom, look at that. That's our 36DB. That's the document for our next thing. Woohoo! Isn't that awesome? And of course, fish has a pointer reference here, 36DC. Boom, down here, turtle. And since turtle is at the end of our linked list, its next value is null. There's nothing after it. So these could be created anywhere. These are now being persisted in a database, and we're keeping track of a cyclical structure via pointer references with MongoDB documents. Am I blowing anyone's mind yet? This is fucking cool. This is rad. And that's all the code for it. We had to do like a bunch of meta stuff just to kind of reset it, make things easier for us. But damn, look at this. We're now initializing, setting up, and we can add things. I mean, blow them up right to size. Oh, this is so cool. Also, this is really huge for one of the ways people talk about MongoDB struggling is with graph data. And one of the ways to solve that is actually implementing graph data structures in memory like this. You can do graphs or linked lists, and you can traverse those linked lists to get graph data structures in memory with MongoDB. No one knows that. No one knows that. That's rad. This is like an actual thing you could actually use in production for massive graph data with your MongoDB documents. Using pointer references with object IDs to create massive data structures that link. Isn't that rad? That's pretty cool. We designed our own data schema for massively scalable graph data. What? I mean, we could do with like multiple children, but like whatever, right? That's how you do it. That's how you do it. Isn't that wild? Actually, you know what would be really cool too? I would actually love to implement a graph data structure memory. And then we could go over BFS and DFS, which are the 2 biggest graph traversing algorithms, via MongoDB documents. I think that'd be so rad. Let me know in the comments if you think that like doing more CS stuff like this would be useful. Because like I said, it's useful for interviewing. It's useful for your life. It's useful for like computer science. It's good for review. But it's also useful as a legitimate data structure you can use in MongoDB for storing graph data. What? How cool is that? How cool? This is legit amazing. Let's see here. It's 12. I've been streaming for an hour. We finished one method. We didn't even finish any other ones. I do want to do one more. Because we did add. I want to do a get. I want to do an insert, update, and a delete. But I don't think we have time to do all of them. What I'm going to do is do one more method. Then I'm going to post the source code for all this if you want to review those 2. Hey, we got a follower. Thank you so much. Okay. Let's just do another one, huh? So we got a bunch of our shit here, but let's go ahead and let's do our get. Because understanding how to traverse a linked list is fundamental to understanding its structure. I'm going to say a blanket statement here. You all watching this right now, it's awesome you're doing that. I don't expect you to grok this material just from watching me yabber on and do some live coding. If you want to learn how to do this, you got to do this yourself. Go home, study, and build a linked list in whatever programming language you use. You got to do it yourself. You got to do it yourself. That's how I grok this stuff. Like, I've just implemented this shit over and over and over again, a million different ways, over and over and over again, ton of different languages, and it just sheer repetition. I've got it locked in my brain. And I can regurgitate it in an interview, any situation I want. Okay, let's go ahead and do this shit though, huh? So let's do our get method, async get. And we're gonna be getting via index. This is the index in here. So like I said, we couldn't get things via index. You kind of can, right? But you have to traverse it via the head. Unlike arrays where we understand, the array tells us the index in memory where it exists. So we can get it in constant time. We have to start at the head, then we have to traverse that linked list via those next pointer references in order to get the node we're looking for. So, if I do get 3, I want to get the third pointer reference in memory, right? Which would be 0, 1, 2, 3, which would be turtle. Right? We'll still do our 0 indexing like arrays, or 0, like 1, here would be dog, right? Because we do start at the head, say, hey, head, this is the ID of the first one you want to start at. And we go here, cool. And then we go to the next one, we go here, blah, blah, blah. Go find this next object in memory. Great, and then we do that, and it's here, and then boom, we retrieve that value. That's how that works, right? So, we have our async get. There we go. This does not look right. That's because I have it outside of our thing. Let's go ahead and pop that into our get. So the first thing I want to do, I want to just do some basic error handling on this. We'll do if index is less than or equal to -1. So if it's a negative number, it doesn't exist. We can't get it. You can't do that. I want to do an error. So we'll do, what do we want to do? We'll do throw new error invalid index. Always do error handling. Good programmers handle errors and write good error messages, right? Okay. So next thing we want to do, right? We start at the head, and we traverse that linked list via pointer references to the new documents. So the first thing obviously we need to do is get the head. Luckily, we already wrote a function that does that for us. I'm just going to take that, paste that down here. We'll get our head reference. And then I want to keep track of our position as we're traversing in memory. Well, actually, we'll do that in a sec. Oh, and then I want to also get the node that we're currently traversing on. So, and in this case, it is going to be the head, the first node. So we'll just do let current node equals await this dot collection dot find. And we want to find the ID, which in this case is wherever our head is. We go find wherever this thing is. I'm gonna call this head. Oops. Colon head. There we go. And just like before with any finds, it returns a cursor. So I just do next so we can get that first cursor reference. All right, let's do a quick test here. CLO. We'll do our current node. We should expect to see our head here when we console log this. Connected. Oh, duh. I had to go ahead and invoke this. So we have our turtle. And let's do a get. And we're going to do get1, which should be our dog. But we're not that far yet. We should just expect to see our head get console logged here. Cur head. Oh, cur node, not cur head. There we go. There we go. And as expected, cat, because that's our first node we inserted into our linked list. That is the first one that pops up. Great. Okay. So now we have to start our loop, right? We just keep traversing those next references till we find the node that we're looking for, which in this case is our index or whatever that is. So I'll do a while loop. Oops. While statement. So while, we have to keep track of our position in this loop. So we'll do let position equals 0. So while position is less than our index, we want to continue doing this loop. Okay, cool. So we're going to keep going through it. So what we have to do then is we have to check to see if we hit the end of our linked list. So that's actually this. Actually, you know what? Let's just add some notes here. Loop through the nodes till we hit the index. Hit the index. And great. First thing we got to consider though is what happens if we have 4 items in our linked list, but what if we hit item 1000 or put index 1000 in there? It's not negative, so it's technically valid. But we're gonna how do we know if that hits the end of the linked list? Let's take a look at that data structure again. Let's look at the tail. What's different about that tail than the other items? The tail has a next value of null. All the rest of them have point reference at the end. So we want to see if our cur node dot next is equal to null, then we know we've hit the end and we're kaput. So let's see here. I don't know if I want to throw a new error. Well, actually, no. Let's do it. Let's be consistent. Throw new error. Index overflow or something. So let's try this. We'll do index of 1000, which is the 1000th index of a 4-node linked list. We should expect to see an error here. Yeah. What else do we want to do here? I want to do a position plus plus. Okay. Why is that valid? Has ever hit this? Oh, I know the problem. It's because we never are updating the current node. Yes. So what happens? We need to actually go ahead and update the current node. And basically, what we do that is we go find the next node in memory, and we save locally in memory, or we find the next node in the database, and we save that in memory at the local thing. So we'll do let's update our current node. Current node is equal to, this dot collection dot find. We want to go get the next value, the next pointer reference in memory. So find underscore ID. We want to do current node dot next. Again, finds return a cursor. So we want to just do the next invoke, get that data from that, and then we should be good to go. So there we go. Now we should be traversing it and updating that position, and we're going to check to see if that's null. Otherwise, we'll return it. Actually, and then we're almost done here. We know we're done. If we hit that index, we have that current node saved. Then all we do is just return that current node. Index overflow. Yes, great. Okay, perfect. That means we're updating, right? Index overflow. Woohoo! We had our error. So now we want to do index of 1. And again, it's going to be 0, 1. So we should be getting back dog here. And we're getting the first one, right? Getting index 1. Actually, you know what I'm going to do? I'm going to do const data, or you know what I'm going to call this, result equals, and this console log result. We should see dog. Woohoo! Right? Dog. What about 2? So that should be 0, 1, 2. We should see fish now. There it is, fish. What about, let me do 3. We should see turtle. There it is. And then if we go 4, it should be an overflow and we should get an error. Holy shit, there it is. What if we do -1? We should see an error. Invalid index. Oh my god. Index of 0. We should see that head, that cat. Oh my gosh. Look at that. Working like a charm. Works like a charm every time. Oh, woo, hoo. Damn. Doesn't that look good? Let's see here. If you're watching this, I'm going to be signing off here in just a moment, but we didn't do remove and we didn't do insert. Insert's the hardest one because you have to do a bunch of key management for head and tail. But I would recommend you go home and try to finish this up by yourself. And try to add additional methods. I didn't even implement any of my code. Like a find. I want to find some data value, and you have to traverse your linked list until you find that value. Right now we're just using index, and we're just traversing to n, whatever, some number of spots in that array or that linked list. But if I want to find data, you could totally do that instead, right? It's the same principle though. Instead of looking for that position, we're just looking for some value to be saved in there. Okay, damn, right? Let's see here. Any questions in the chat? Any questions in the chat? I'm going to post this gist in here. So this is our complete list of that data on there. So if you want to check that out, go ahead. That's a complete code with a bunch of other stuff in it. I want to plug a bunch of stuff though. So if you enjoyed this, I'm going to be doing a bunch more. Let me know if this is useful to you. I would love to do, again, graphs. I would love to do graph traversing with MongoDB documents. And these are all CS 101 basic stuff you should be knowing. And these are essential for getting through interviews, especially at FANG companies. The big 5, right? Want to make sure you get through all those. If you haven't already, MongoDB Live is coming up June 9th and 10th. I'm going to be giving 2 talks, and I'll be running the Twitch stream with my friend Rebecca. She's been in the chat here today. You should totally check those out. Yeah, they're great. You should totally check those out. Let's see here. I don't know where those things are. And then, you should check out, we have a new university or dev hub. So if you go to developer.mongodb.com, we got a bunch of amazing articles on there if you want to find out more stuff like this. I'm probably going to be turning this broadcast into a post on there soon. So I think this is super cool and useful. Yeah, let's see here. The community, if you have questions about MongoDB, you should check out community.mongodb.com. Yeah, let's see here. Rebecca, do you want to follow us on Twitter? I don't know if Rebecca, if you want to post your Twitter account. She runs our social here. I just posted my personal Twitter account in the chat. You should totally go check that out. I mostly post funny programming jokes, post a lot about JavaScript, obviously post about NoSQL, MongoDB, etc., etc. Yeah, I post a lot about CS fundamentals too. I know you guys can't get enough of just like programming 101, and I want to help you guys learn how to be better programmers. Live, yes. So Rebecca and I will be hosting. So if you go to mongodb.com or mongodb.live, I'm going to post a link in here too. So World is usually in person, and it's usually a paid event. MongoDB Live is totally free and open to the public. It's June 9th and 10th. Rebecca and I are going to be running a live stream here. I'm giving 2 talks. I'm giving a talk on a brand new GraphQL endpoint, and also giving a joint talk with my sister about a really cool side project I built about the Bechtel test. But you should totally sign up. Again, it's totally free. Just go sign up. It's virtual, free, accessible, online, streaming. There's on demand. There's going to be asking experts. You can totally do whatever you want with that. Okay. Let's see here. DM me on whatever. Connect me on LinkedIn. Oh, careers. If you want to work for MongoDB, again, we're looking for our next intern class. And I have a feeling here a lot of people want to either work for MongoDB or potentially be part of an intern class. It's going to be totally remote this year. You should totally go in and check out jobs. If you see one that's interesting, DM me on Instagram or Twitter or LinkedIn, and I'd love to refer you. Love to help you get in. I do career prep stuff every Wednesday on Instagram, so you should totally come check that out there too. Let's see here. Any other questions from the audience before we sign out here today? Again, I don't expect you to be experts at this after this one talk. I want you to go home. I want you to program this yourself. That's the only way to learn this truly. You need to make sure you're so good at it, you can adapt any of these problems into an interview problem. You'll never be asked to do this directly. you'll ask to adapt it for real world type situations. Like, hey, implement a round robin load balancer. You're going to think to yourself, damn, a circular linked list would be great for this. I need to implement this using this real world problem. Right? That's what you got to do. Oh, yeah, Rebecca, thank you. We have our podcast. Yes. You may not know this too, but MongoDB has a new podcast. We interview startups. We talk to new people. Yes, I was on the podcast. Yeah, I was talking about our new GraphQL endpoint, which you don't know is incredibly cool. You hit a button, and GraphQL automatically generates a GraphQL schema for you and a GraphQL endpoint. It's literally, you hit a button, it turns all of your data into a GraphQL server. I don't make servers anymore. I'm literally just using this endpoint for all my projects these days. No joke. It's so amazing. You got to check it out. Okay. I think that's it. I hope you guys are inspired. I hope this is useful. If this is useful, I appreciate it if you tweet that out. Tweet at the MongoDB account. Tweet at me. If you have suggestions for future shows, I want to make stuff that is useful for all of you. I want to make things that like help you learn and grow. And I want to know what that is. I have ideas. Like, again, I'd love to do graph traversing. I'd love to do depth first search and BFS. I'd love to do more of these fundamental series. Rebecca and I are going to be actually hosting an upcoming stream about how to actually get the most out of virtual conferences. We'll be doing that in the lead up to live. But even if you're not going to live, you should still be able to get useful information about how to actually, because the new world is virtual conferences. And how do you succeed in this new world of virtual learning? I think in tech, we need to make sure that we're understanding that and like adapting well. I think the people who are probably in the stream right now are better able to handle that, but like, you never know. Oh yeah, Rebecca, thank you. Damn, I forget so much, Rebecca. Rebecca's like my second brain. I'll be hosting a stream on, I think it's on, next Wednesday or Tuesday. Let me double check my calendar. But I'll be on the MongoDB live account, doing some live streaming on that Instagram. We're talking about like just live, again, getting prepped and answering just general questions you have about MongoDB. I'm probably going to do a lot of career questions, what we're looking for, how to get ready for a job, how to get ready for live, what to expect, that sort of thing. But I'm giving that at 11:30 Central Time or 12:30 Eastern Time on the MongoDB Instagram. So if you don't follow them, make sure you follow the MongoDB Instagram account, which I'll post a link to here. Oh. Yes, oh, thank you. Oh, and then if you want $100 in Atlas credits, use code Joe K100. If you do sign up, it helps me it helps show my boss that you guys thought this was useful enough to sign up. So it really actually helps me out a lot if you sign up using that code. Which is awesome. Plus, you get $100 for free. I've been using the free tier forever, and I've never needed to go over it. But like, hey, what the hell? If you are going to, go ahead. It's nice to just keep some money in your back pocket in case you go over for whatever reason. Maybe your app blows up, and now you have a couple bucks to buffer, so you don't have to actually pay anything. Okay. I think that's it. I just want to say again, I love you all so much. You're amazing. I can't believe you guys have made this broadcast so much fun. This went so smoothly. I think honestly this is probably the first broadcast where I haven't fucked something up when I'm broadcasting, so this has been pretty good. Yeah, if you want to talk to me about programming, MongoDB, JavaScript, Node, career, anything, I'm here for you. Right? No judgments. I'm here for you. All right, y'all. Well, I'm gonna sign off. I'll see you guys soon, and remember, keep programming. Bye, y'all.